All right, we're back again. Week 2, exam 2 for CNBT 1342. All right, let's go. Let's get through this. All right. The IBC, Uniform Building Code, and the IBC, they defined two major subdivisions of materials to be used in buildings. They're defined as combustible materials and non-combustible materials. Combustible and non-combustible. Now, what makes a combustible material and a non-combustible material? It is a test according to ASTM, American Society of Testing Materials, E119. Standard test materials for fire test of building construction and materials. Underwriters Laboratory used to lead the charge on this, and Underwriters Laboratory standards there, but this is according to ASTM, the American Society of Testing Materials. All right, so let's look at some materials. Structural steel, now it's non-combustible. However, you can get it hot enough to melt and burn. So the strength of steel remains essentially unchanged until about 600 degrees Fahrenheit. The steel retains about 50% of its strength at 1100 degrees Fahrenheit. The steel loses all of its capacity when it melts at about 2700 degrees Fahrenheit. This is according to the AISC, American Institute of Steel Construction. That's how we glue it together with electricity. We're melting it, right? Anyway, if you care, take a screenshot of this and you can go read this link on the AISC website. Let's go to reinforced steel, reinforced concrete, reinforced concrete, sorry about that. At temperatures in excess of 260 degrees C, and I don't live in sea land, 500 degrees Fahrenheit, rebar can become brittle. We call it blue brittleness. And at temperatures in excess of 1300 degrees Fahrenheit, rebar can lose 20% of its design strength. Structural failure of reinforced concrete often occurs when the effective tensile strength of the reinforcing steel is lost through the heating. Now, you can increase the cover of the reinforcing steel, but unlike structural steel, concrete, when it does decide to fail, it's generally a catastrophic failure. Okay? All right. And if you really care, and I don't care if you care or not, I'm going to read it anyway because I'm a geek. All right? The potential chemical changes in concrete exposed to heat of a fire include aggregate changes, and depending on what kind of aggregates in the concrete. You got quartz-based aggregates, they increase in volume. In other words, they swell. Limestone aggregates, they break down and decompose. Discoloration due to changes in the concrete compounds. Concrete will turn pink as a result of chemical changes in compounds containing iron in the concrete. Carbonation, the breakdown of the cement paste in concrete, results in a reduction in alkalinity or a protective coating which promotes corrosion of the rebar. The pink discoloration indicates chemical changes in the iron-containing compounds, and that occurs when temperatures are greater than 570 degrees Fahrenheit for an extended period and indicates damage beyond repair and requires replacement of the concrete. And concrete erasing is very, very expensive. Concrete properties do not reverse themselves as opposed to steel. This is due to the transformations of the physical and chemical properties of the cement itself. So theoretically, you can heat up a structural steel frame, extinguish the fire, it goes back to ambient temperature, assuming it doesn't reach 1100 degrees Fahrenheit, and theoretically it can be deemed as still serviceable. This, of course, will be dependent upon your engineer after the analysis. And the fire's put out, of course. All right, moving right along. All right, the IBC classifies all buildings into 5 broad categories. Five broad categories. And here they are. Okay, type 1, type 2, type 3, type 4, and type 5. All right. This is from that section table. You can go read it if you want. This is the most fire resistive on this end. This is the least fire resistive on this end. So what the designer would do, will enter from the occupancy group. You enter here and slide into the tables in chapter 5 and then go up. Okay. All right. So we've got 5 broad groups. Now, what is a non-combustible material? Oh my, looky here. There's the definition of non-combustible materials. Okay? And they include masonry, concrete, and steel. That doesn't mean they won't get destroyed by fire. It doesn't mean that they won't be damaged by it, but they won't burn and change into a basal carbon structure like wood will. Okay? And then here's the definition of combustible materials. All right? So, if you haven't figured out by now, these lectures are guiding you through what I consider to be the salient parts of the code. Now, you can go into the code and you can look at all the different types, okay, of the combustible and non-combustible. All right, so here's another ASTME designation, and note that the application of additional fire protection materials to the non-combustible elements of types 1 and 2 construction yields higher type, like a 1A or 1B or a 2A rating, etc., etc. You can stack these, okay? All right. Just like for fire retardant systems for structural steel. There are companies that specialize in this. And you and your building code people will be able to determine what y'all think is the absolute best. So again, non-combustible materials include masonry, concrete, and steel. All right. Wood and plastic are obviously combustible. Now, wood burns and gives off carbon monoxide and water vapor. And if it's treated, depending on what it's treated with, if it's treated wood, there will be some noxious VOCs, volatile organic compounds, in the smoke. Plastic, on the other hand, carpet, plastic, that's some nasty, nasty stuff. When it burns, the basal elements of it, and the basal elements of most plastic is a cyanide-based chemical. So guess what's in the smoke? Cyanide. Okay. All right. All right. All right. Let's see here. And if it's hydrogen cyanide, something like that. Yeah, but it's cyanide. And some other nasty, nasty stuff. It will kill you. All right. Let's see. Let's move on down. All right. And what's the minimum temperature at which steel begins to lose its strength? We've already gone over that. Okay. And let's see. Passive fire protection. What is passive fire protection? Well, passive just means that it's made out of non-combustible materials. Okay? Okay. If you spray all your structural steel or cover it, okay, then this would be passive. And then if you have a sprinkler system, like shown in this diagram, this is going to be active. This is your active fire protection system, all right? And your passive fire resistance, like we said, is the use of construction materials and the assemblies that can be expected to withstand exposure to fire. So there's your two passive and active fire systems. All right. Now, can a building be composed of combustible and non-combustible materials? Absolutely. Let's assume this was a structural frame. All right. And then maybe you had a wooden floor up here. All right. Typical wood flooring. And it's supported by a steel frame. So, can a building be composed of both non-combustible and combustible materials? Well, the obvious answer would be yes. Okay. All right. All right. And this gives you some more diagrams. You can read through this of mixing framing materials. All right. Let's see. And this is talking about balancing the tables and openings and setbacks from other occupancies, like if this was a house over here or something. All right. And they talk about how the hour rating of the wall for the fire. All right. Okay. All right. Let's see if we can go down and find concealed spaces. There's type 1 and 2 construction. Talks about the difference. Okay. Now, obviously, this is wood. It's combustible, but this might be cast in place concrete wall or tilt wall. All right. And then you've got light gauge steel up here. Okay. And that's type 3 construction. It talks about that. We went through some of this in CNBT 1311. Okay. And more of the different types of construction. This is heavy timber down here, and flooring elements, mass timber, that sort of thing. We're not going to dive too deep into the weeds on all this. We could spend several weeks just in chapter 6. Okay. Just in chapter 6. Concealed spaces. This is something you as the designer really need to be careful about. And that's why I'm stressing it in my humble expert farmer engineering opinion. Okay. Is a concealed space have historically been prohibited in heavy timber buildings. Historically. They are now allowed if they meet certain conditions. And what would that be? Perhaps an active sprinkling system in the concealed space? So what is a concealed space? Okay. Items inside concealed spaces, it's just that. They're in a concealed space. All right. Must be non-combustible except for building elements and electrical, mechanical, and fire protection or plumbing materials and equipment permitted in under the mechanical place. So you could sprinkle these things. You could wrap it with fire retardant. Okay. The concealed spaces. You can apply a minimum of 5/8 inch type X gypsum board. Remember I said in the previous video, it has to be a certain type of gypsum sheetrock, not the crap you get at Home Depot or Lowe's. Okay. And depending on your fire rating, that you're trying to obtain, you may need several layers of that. It may need to be an inch. Who knows? Depending on what hour fire rating you want. We'll talk about that later. All right. So this is an active system. These would be what? Passive. Okay. Because we're building them out of a non-combustible insulation and fire-resistant gypsum. Okay. Let's see. Least fire resistant. We're talking about layering this stuff. Okay, that's chapter 6. Let's go into chapter 7. Fire resistive construction. And what's the codes? The code has basically two basic methods for providing fire resistive protection. We've already talked about that in chapter 6. I guess I better do my marker gizmo. Let's get that out here. Well, obviously it's passive and active. And again, what is the passive? Passive is made out of non-combustible materials, are fire-resistant materials. Active would be a sprinkler system, or in some cases maybe argon gas, an inert gas, right? And this goes into the ASTM testing, the time and temperature curve and all this junk, but I'm not gonna beat you up over that. Okay? All right. Okay. So, we already talked about what passive protection is. We've talked about what active protection is. Now remember, active protection is both sprinklers and smoke remediation. When we talked about that in the atriums, right? Smoke ventilation is also an active system. And like in something like an electronic room, an electrical room where you don't want water sprinkling in, you would use an inert gas and airtight doors. And God help you if you're inside there when that stuff kicks off, because it dispels all the oxygen and you will die. So I guess it's better to die of suffocation than be burned to death. I don't know. Or die of smoke inhalation. Okay. Fire resistive ratings. Okay. This talks about fire resistive ratings. Okay. So you might be asked a question. Well, you will be asked a question. What is a fire resistive rating? What is it? Define it. And you'll find that answer in here. Okay. All right. Fire resistance of structural members. What is a projection? Okay. This talks about fire resistance of structural members. We talked about spraying them, wrapping them, boxing them in with sheetrock, extra cover for your reinforcing steel for your concrete. All right. Projections. What is a projection? This defines a projection. It projects out of the building. Okay. This is the projection distances, are based on fire separation distances from a table in the code. All right. It's a piece of the wall that projects out from the wall, and the fire separation distance is also D from the exterior wall to a line to determine fire separation from another structure, and that's what this is. That's your line. Okay. And this is no projections are allowed when D is less than 2 feet. Okay, all right. So this is your projection distance. So if you're butting up against another structure, you may have to back this off a bit. All right. They're going to check this in your design plan. This is where you'll find your projections, okay? And this gives you what some projections are, okay? So they're eaves, they're overhangs, they're cornices, they're balconies that extend beyond the exterior wall. Hidden away in here is it is cornices, eaves, and balconies. Okay, all right. That's a projection. Now, projections extending within 5 feet of the lot line. You saw the lot line before. Okay. Projections extending to within 5 feet of the lot line are to be one of the following materials. They're made of non-combustible materials, one of fire, 1 hour, heavy timber, fire retardant treated wood, are as permitted by the IBC code number right here. Okay, so there are 5 of these, and they got to be one of the 5. So if you're asked to list all 5, then you can do that. You know where it's at. All right. Multiple buildings on a site. You go through that. This table allows exterior walls to have a certain amount of openings, vertical exposure, okay, parapets, for fire jumping over the parapets. And we talked about there's no openings here, okay. Structural stability. This is something you need, you and your structural engineer and your authority having jurisdiction. Well, what is the structural stability? Structural stability is simply in regards to firewalls, that they're so designed that it stays in place for the duration of the fire rating while the structure collapses on either side of it. Okay? So let's say this is your firewall. Okay? This is your firewall. So you got a structure over here, and the fire's over here, and they're suppressing it, and there's no fire over here, but you got this firewall. So this wall stays intact for the duration of the burn, or while they're trying to suppress it, and allows this side to collapse due to the fire, depending on what it's made out of, or sag if it's steel. It'll still collapse while the firewall stays in place. That's your structural stability. All right. Horizontal continuity. Specifies that firewalls are to be continuous horizontally from exterior wall to exterior wall and extend at least 18 inches beyond the exterior surface of the exterior wall. So if it was like, you've seen this in apartment complexes on balconies, where in between each unit is a firewall, and that firewall extends out at least 18 inches. Some of them go all the way to the end of the balcony to seal off the balcony. But that keeps the fire from jumping from one unit to the next unit. Let's say there were 2 units in here, and we got another firewall. Okay? All right. this talks about firewalls in plan view. Okay. And it could terminate at the interior surface. It could. But horizontal continuity of the firewall. Okay. So in plan, let's say we have one unit here. And we have another unit over here. And in between each unit is a firewall. And let's say this is a high-rise condo or something. And this is your balcony. Some designers will extend the firewall all the way to the balcony. And it also serves as security. So one drunk goober just can't jump over the railing and come visit you when you don't want them to visit. But more importantly, it keeps a fire in this unit contained and helps it not jump into the next unit. And that's what they're talking about. Okay? And this is a good example of continuity. This is the firewall. This is the firewall. And you see, if this was like the main living area of the condo and this is an outside balcony, Missy can come over here and enjoy her mint julep while the next apartment is burning, which she wouldn't do. They'd evacuate the bloody building. But that's what it's all about. It just helps contain the fire. So the suppression team can come in here and deal with this whole unit. The other unit probably going to have smoke damage, but that's it. All right. Now, we want to talk about vertical continuity. Just like horizontal continuity, it's the same thing. Okay, we have vertical continuity. Firewalls extend up, okay, from the building foundation to a point at least above the adjacent roofs. Okay, so if this unit's on fire, it's something to protect the fire jump. Okay, all right. All right. Penetrations. Penetrations and joints. Okay. All right. Ducts are not allowed to penetrate firewalls on property lines. Exceptions allow ducts and walls on lot lines. Okay, so there are some code restrictions for this. Okay, now openings have their own code restriction. Okay, the two types of penetrations are through and membrane. Okay, through penetrations and membranes. Through and membrane are the two types of penetrations. Okay. Then you got fire barriers, and there are companies that specialize in fire door dampers, automatic links that fray, and stuff like that. Okay. So the two types of penetrations are through penetrations and membrane penetrations. Through penetrations in membrane. Okay. Okay, let's go down through this. All right. And this talks about occupancies and what you can do. Smoke barriers and smoke partitions, floor and roof assemblies. Okay. And this is more vertical openings. Expansion joints of other floor walls need to be enclosed, but they must be protected. Ducts and air, dampers, pipe and vent and conduit. There's all kinds of things you got to take into account. All right. There are two types of penetrations: through penetrations and membranes. And we could spend a lot of time on this. Shaft enclosures. Okay. All right. Other membrane penetrations that go through only a portion. Penetrations are two basic types. I already told you this. One is a through penetration that by definition passes through an entire assembly, and the other penetration only goes part way through the wall partition. Okay, so this is an example of a membrane, and this is an example of a through. This is one of the things I don't like about Ching, is he likes to break this stuff up. This talks about how you detail these penetrations. All right, here's another example of two membrane penetrations. So what might this be? This might be an electrical box, right? And then here would be your conduit, home run conduit, running through down the wall. Okay, this would be a pipe coming through. Any space of this, there are people that specialize in selling these things that are fire rated with the right type of fire rating. All right. Okay. So every penetration, plumbing, you name it. The devil is in the details. All right. This whole thing goes to the different kinds of openings. Okay. Marking the openings. What does it mean? You may have to do this as a designer. Protective openings. How you label them. Your push bars. Where are they at? It's got to be ADA, right? We go back into that in egress and access. Yeah. Okay. All right. More concealed spaces. We get back into concealed spaces again. See, he bounces around a lot. I don't particularly like that. All right. Stairwell runners, where you've got two stringers, and if this was my wooden stair system and you built a set of designed a wooden stairs with just two stringers, I'd fire you. I told you all that in CNBT 1311. You always use a middle stringer. It keeps the drumming effect out of your stairs. Okay? Anyway, I digress. You got to worry about this. What happens? Because you've got a fire down here or fire up there. It's gonna. If you got a fire down here, the heat's gonna run up and the gas is gonna plume. So you might have to put fire blocking in here, or use a combination of non-combustible materials to enclose this enclosed space. All right. And you got thermal and sound insulating materials. All right, there's all kinds of insulating materials. Here we go again. We've already talked about this, right? Alternative methods of fireproofing. And this gives you an idea in this section of how much time you've gained by doing these certain things, these different types of details. All right. Wall partitions. Again, the detailing. So what do you think is going to happen? You got a fire down here and you don't have an active sprinkler system. Well, this tie wire up here is going to elongate, right? And your suspended ceiling may come down. So that's why even all these office buildings are sprinkler heads all down in here. All right. But with the general construction details, these are rules of thumb. This gives you a 1 hour fire resistant rating. That gives you 1 hour. Okay, your mileage is going to vary. Calculated fire resistances. There's formulas you can go through. You start building stuff up. More concrete you put over it, more covering. Maybe you come in here and you spray foam on there, the details for your expansion joints. That has a fire rating. All right. And no, you're not going to be asked. You've already seen the exam, so I'm not going to make you go through these calculations. If I was a mean old man, I would, but I'm not going to. Okay? All right. Wood assemblies. Cedar shake is a bad idea. Wood shakes are a bad idea. You use hardy siding. Stuff doesn't burn. It's made out of cement. I mean, come on. All right. Hint, hint. Hint, hint. 1/2 inch type X gypsum board gives you 25 minutes of running out of the building time. 5/8 inch type X gypsum board gives you approximately 40 minutes. Okay. 1/2 inch is 4/8, right? So an extra 1/8 of an inch gains you 40 minutes. So if you put like 3 or 4 of these 5/8, then you're stacking all this up, and you can go back through your calculations up here and figure out what your fire rating is going to be. You get with your fire marshal in your local area and your building inspector and in the pre-design meeting, and guess what? You can come up with a plan. All right, let's move on to Chapter 8. Move on to Chapter 8. Interior finishes. Okay. All right, wall and ceiling finishes are classified by what? Well, you will find that the primary consideration of this chapter is the flame spread and smoke generation characteristics of materials when they're applied to underlying surfaces. All right. So, your wall and ceiling finishes are classified by their flame spread and their smoke generation. Okay. There you go. That's how they're classified. And every material has their own flame spread rating and smoke generation rating. And no, we're not going to go through every single bloody material, okay? But you can see here class A, B, and C, and here's your index and your smoke development index. And that all ties back to a code and UL. There's the underwriter's laboratory again. UL sets a standard, and they still do. All right. And ASTM's got a standard for everything. Latex gloves, condoms, tires, you name it. There is an ASTM standard, testing standard for everything manufactured. Okay. All right. There's a flame spread box. Okay. All right. The required classes as a finished materials are defined by what? What are they defined by? It's another question. All right. How are they defined? Well, are we talking about occupancies, right? So we're going to go back to occupancies. All right. They are defined by the occupancy. Okay. Non-combustible trim, fixed or movable, in auditoriums of Group A occupancy, okay, taken from the International Code, Fire Code, the IFC. All right. Here it goes back to suspension systems again, depending on your fire rating. All right. So, the required classes of finished materials are determined by your occupancy. The requirements are further subdivided in 2 occupancies, sprinklered and unsprinklered. Is it an unsprinklered occupancy? Is it a sprinkled occupancy? And the final consideration of finished materials occurs in what two areas? Well, it's going to occur in the exit and access areas or rooms, which makes sense, okay? The final consideration of what materials that you use are going to determine where it is. And the two critical areas are your exit areas, your access areas or rooms. Access to an exit. Access to a room that's not on fire, okay? Wall and ceiling finishes. The required classes of finishes and materials are determined by occupancy, okay? And the requirements are further subdivided into sprinklered and unsprinklered, okay? The final consideration, so there's actually three things in here, right? Three things of importance. Three questions, all right? Is whether the finish occurs in exits, in exit access areas, or in rooms per this table, all right? All right. There we go. Okay? All right. So again, three things of importance here. Wall and ceiling finishes by the exit sign on page 158 of your book. All right. Is the occupancy, is it sprinkled or is it unsprinkled? Which makes sense, doesn't it? Okay. And if it's sprinkled, you buy you more time. If it's unsprinkled, well, you got a problem. And the final consideration, again, is where this is at. Is it an exit? You don't want your fire exits, your exits out of the building, your emergency exits, to be all combustible materials, right? You go down to the Toyota Center, you go down those stairs, all that stuff is concrete. All the way out the door, the exit door. Okay. All right. All right, so we're going to move on to chapter 9. That's pretty easy. There are only 4 questions out of chapter 8. Could have been a lot more, but we're at 42 minutes. I'm going to go ahead and kill this video here, and then we'll pick up chapter 9 and 10 in a next video. Okay? All right. Thank you for your patience. Follow along the videos in the book with your exam, and it will speed things up because we don't have a lot of time in this 6-week session. All right.